Okay, now we'll start with average and RMS value of a waveform. So let's see what are those. Okay, so average, so you already know what is average, and RMS means root mean square. So we'll come to this. So let's start with average first, average value of a waveform. Okay, so by definition, what is average value? Average value is equal to area under the curve by duration of the curve. Okay, so this is the definition of average value. So suppose I have a curve like this. Suppose I'm denoting as ft, the function of t. This is the curve. So what will be the average value? Okay, so what is the area under the curve? So area under the curve is, suppose this is 0, this is t, t1. Area will be from 0 to t1 ft dt. So this is the area. And what is the duration? Duration is t1 minus 0 is equal to t1. So what is the average value of this waveform? It will be 0 to t1 ft dt divided by t1. Fine. Okay. So now let's consider how to find the average value of a periodic waveform. If the waveform is periodic, how to find this average value? How to find the average value? Okay, what is periodic waveform? So basically periodic waveform are the types of waveform that repeats itself after a certain amount of time, means after every certain amount of time it repeats its shape. Okay, for example, the most common is the sinusoidal. So sinusoidal is like this, continues for like infinite duration. Suppose again I am denoting as the f function of t. Suppose the maximum value is a, the negative maximum is minus a. So you can see that after this much period, after this much duration, the waveform keeps repeating. So here after, you can see, so after this much duration the waveform keeps repeating, and the duration after which the waveform keeps repeating we call this as period. Okay, and if the y-axis is in time, then it will be time period. Fine. So if you want to find the average value of a periodic waveform, that the formula is, suppose I am writing ft average will be 1 by period integration of 0 to period that function itself dt. Okay, this is the average value of a periodic waveform. Value of periodic waveform. Okay, and this period will be seconds, hours, millisecond, whatever. Okay, because in y-axis we are considering time, so this will be time period. Fine. See, sometimes AC quantities, mainly if you consider sinusoidal quantities, we express the such AC quantities, the y-axis as omega t or in radians. So we can obviously we can also express this in time, but the general trend is that we express this in radians. Okay, means omega t. So in that case, okay, all these are like pi, twice pi, like that. So in that case, when the y-axis is in radians, so we find the average value, again same formula. Then this f will be f function of omega t here, not function of time, it will be function of omega t. 7 omega t d omega t. Previously it was dt, now it will be in omega t, and now this period, this will be in terms of radians. Fine. Depending on the y axis, whether it is in radians or in time. If it is in time, then this period will be in terms of unit of time, that is seconds, example seconds, and if it is the y axis in radians, then this period will be expressed in terms of radians. So let's take few examples. So let's start with so example one. Let's start with this waveform. Okay, a pulse train. So this is a function. Suppose the maximum value is a 0. Suppose this is t, twice t, 3t, 4t, like that. Okay. So I need to find the average value of this waveform. So what will be the average value? It will be 1 by period. What is the period here? Here the period is this thing. Sorry, here the period will be this much, because every 2t seconds the waveform keeps repeating here. Okay, so this is the first waveform. The same waveform can repeats again here, the third waveform here, like this it keeps repeating. Okay, okay. So 1 by period, what is period? 1 by twice t, integration of 0 to twice t, ft dt. Suppose this is time. Okay, so if we break it little, it will be 0 to t. We are breaking this into basically into two parts, 0 to t and t to twice t. So t to twice t ft dt. And so here, from here you can see that from t to twice t the function value is 0, so it will be obviously 0, the function value is 0. So from 0 to t the function value is a. See, from 0 to t, what is the function value? Function value is a, so I am writing it as a here. Okay, a t. Okay, if I now integrate this, it will be to a integration of t dt. What will be the value? 1 by twice t a into t to 0. Integration of dt will be t, and it will go from 0 to t, so it will be a by twice t into t, cancel a by t. Okay, so average value of a pulse train will be a by 2. Fine. let's consider another waveform. So let's consider sinusoidal. Suppose a minus a ft is equal to a sin omega t, where y-axis is omega t gradients by twice pi. So what will be the average value? So by the waveform you can guess the average value. So obviously this average value will be 0 because the positive part will be cancelled out by the negative part. So overall we will get 0. So what is the period here? Period here is 2s pi, because every twice pi seconds as twice pi radians the waveform gets repeated. So it will be twice pi 0 to twice pi a sin omega t d omega t. Okay, if you break this, 0 to pi a sin omega t d omega t plus pi by twice pi a sin omega t d omega t. Fine. So this is the area of the positive part, and this is the area of the negative part. Fine. So this positive part, obviously it will be positive, and this part will be also magnitudically magnitude wise it will be same, but it will be have a minus sign because it is in negative direction. So this part and this part will get cancel each other, this part and this part will cancel each other, the overall will get 0. Okay, ft average will be 0. The average value of a sinusoid is 0. Okay, so now let's, in third case, let's take DC, a DC signal. Suppose this is a DC signal. Okay, so what will be the average value of a DC signal? Again, average value 1 by period 0 to period ft dt. Okay, now what is the time period of a DC waveform? See, what was time period? So time period is the duration after which the waveform repeats itself. But for DC we can see it is a constant and it goes for like infinite time. For infinite seconds it will be the constant value, it will give a constant value. So when it will repeat itself? So basically the time period of a DC is undefined. We don't know what is the time period. So if you search in literature, like if you search in Google, so you can also find across sources where they tell that the time period of a DC waveform is infinite. Few may say time period is 0. So which is true? Which one to consider? See, actually the time period is undefined. Basically means we don't know what is the value of t. So I can say that you can take, for a time period of a DC waveform, you can take any value of your choice, and it will be hold good. Okay, let's suppose I'm saying that time period of a DC is 2 seconds. Okay, I'm telling time period of a DC is 2 seconds. Let's consider 2 seconds and see. So when I say time period of a DC is 2 seconds, so what does it mean is that for every 2 seconds there is waveform repeats itself. Okay, for 2 2 seconds the waveform's value is A. Okay, so after again 2 seconds it will keep constant for another 2 seconds. So like this it can continue 6 seconds, so continue. So overall you can see that it matches the original waveform. So t is equal to 2 seconds is fine. So what I want to say is that you can consider the time period of a DC as any value. That's why we call it as it's undefined. Means it's not defined. What is the value of t? So what is the value of the time period of a DC? So t can be anything for a DC waveform. So when we will find the average value of a DC waveform, so better not to write any particular, not to give any particular value to the time period t. Let's keep it as t only. Okay, so if I give the value as t, so it will be 1 by t 0 to t. From 0 to t can be anything, and whatever we choose the value of t, the function value will be a only. Okay, this is the average value of DC. So if we break, what will we get? 0 to t dt. Okay, it will be a by t into integration of dt will be t, and it will go from 0 to capital T. So after that equal to a. Fine. So the average value of a DC signal will be, here we have considered the DC value as a, it will be at a. So if you have a DC value, DC signal whose say DC signal of say 5 volts or 5 amperes, so what will be the average value of a 5 volt DC? It will be 5. What will be the average value of a 5 ampere DC? It will be 5. Fine. So let's consider another waveform. Which ones? Suppose this. This is actually the output waveform of a half wave rectifier. Okay, we'll study later about half wave rectifier. This is the output waveform of a, this is a full wave rectifier. Output waveform of a full wave rectifier. Okay, so suppose omega t pi twice pi, suppose a, and we give it the x-axis as a name function ft. Fine, we need to find the average value of this waveform. So what is the period here? Here the period is pi. So every pi radians the waveform keeps repeating. Okay, so let's find the average value. It will be 1 by pi 0 to pi, and from 0 to pi to, okay, so 0 to pi the function will be a sin omega t d omega t. Okay, let's calculate. We can take a outside, a by pi. What is the integration of sin omega t? It is minus cos omega t. It will be, the integration will go from 0 to pi, a by pi. Let's keep the negative minus outside of the bracket, cos of pi minus cos of 0. Okay, what is cos of pi? Cos of pi is minus 1, and what is cos of 0? It is 1. Okay, it will be total twice a by pi. Okay, the average value of full wave rectified output is twice a by pi, where a is the maximum or the peak value of the waveform. So next, let's consider another signal. Let's consider the output waveform of a half wave rectified output. Half wave rectified output looks like this. Okay. This pi, twice pi, this omega t, a function of t. Fine. So here what is the period? Here the period is up to twice pi, because now every twice pi radians the waveform repeats itself. So after twice pi the waveform looks like this. So again after twice pi it will repeat itself like this, it will continue. Fine. So let's find the average value. Time period is twice pi, it will be 0 to twice pi. Sorry, this now it's a function of omega t, function of omega t d omega t. Okay, we can break this into two pi's. 0 to pi function of omega t d omega t plus pi to twice pi. Okay, from the signal we can see from that from pi to twice pi the function value is 0, so it will be 0. Okay, and from 0 to pi the function value is a sine omega t d omega t. Okay, we can bring a outside, and what is the integration of sine omega t? It will be cos omega t pi by 0 v a by twice pi minus cos of pi minus cos of 0 a by twice pi into 2. Okay, 2 to cancel, it will be a by pi. Okay, so the average value of a half wave rectified output, this one, the average waveform average value of the half wave rectified output will be a by pi. Fine. So let's take another case. Let's consider, let's see, check the average value of, say, sawtooth. So this is sawtooth waveform. So t twice t. So what is the period here? This is the period is t. So average value will be 1 by t 0 t function of t dt. So what is the function value, means the equation of the waveform from 0 to 2, 0 to t, 0 to t. What is the equation of ft? You can see it is like this. I am drawing separately. Suppose 0, this is the waveform looks like. So this is straight line which can be represented as y is equal to mx plus c. What is y here? Here y here is ft, because the y here will be, this is actually y here, this is actually x here, right? And what is m and c? C is the bias, this is the bias. We can see that the waveform starts from 0. If the waveform starts from 0, the c value is 0. Okay, had it been the waveform starts like this, suppose a here, this a, then the value of c here it will be a. Okay, similarly with the waveform look like this, minus a, c value will be minus a, right? So here the c value will be 0. And what is m? M is the slope, m is the slope. So what is this, how to find the slope of a waveform? The slope of a waveform can be found using tan theta. This is the theta. Now what will be the slope? Slope will be a by t. Okay, this is m. M is basically the slope. It will be a by t into what is x in our case? X is t. T. It will be t. Okay. So here we can write 0 to t, a by t into t dt, a by t square integration of t into dt 0 to t. It will be, what is the integration of t? T square by 2, and the integration will go from 0 to capital T. So this will be 2, we can bring outside, it will be t square minus 0. Okay, t square to square cancel, we'll get a by 2. So the average value of this sawtooth waveform will be a by 2. This is sawtooth waveform. Fine. So next, which case we can consider? What will be the average value of this waveform? So here this is the period, and we can see within one period the positive area will be cancelled out by the negative area, so the average value will be 0 here. Fine. So any more case? Okay, for average this much will do. Okay, so next we'll start with root mean square value of a waveform, means how to find the root mean square value. Okay, thank you.